interactive audiovisual experiences with the lead motion, but it's too long, so I kind of shortened it to the project name that I'm developing called Lotus. And yeah, my name is Eddie Lee, and I am a programmer. I do mostly graphics programming, and also do audio synthesis engine, gameplay programming, and stuff like that. And formerly, I used to work at Q Games, but I left the company, as I said earlier, 2 months ago, and now I'm independent. And actually was here a few months ago, I think in January, to talk about the technology behind the demo I made for the Tokyo Demo Scene competition this year, 2015. It's called Artifacts, and actually won first place in that one. So.
Yeah.
As a consolation, I got a NVIDIA GeForce GTX 680, so it's pretty nice. Kind of using that for development. And okay, now that that's out of the way, so I'm here today to talk about this device here called the Leap Motion. So for those of you who don't know what a Leap Motion is, it's sort of like the Microsoft Xbox Kinect, which it's sort of like a motion detection controller device. But as opposed to the Kinect, where it's more, you have this thing that you put on top of the TV, and it recognizes your skeletal shapes in a very low frequency way. And if you look at like debug renders of what the Kinect sees, it's usually very blobby, skeleton figures, not very accurate. But the Leap Motion is sort of the opposite, in which it focuses more on like, fine-grained accuracy. It's very fast. I think it has about 120 hertz of response and about 3 or 4 milliseconds of latency, so it's very accurate, or very fast, and it's also very accurate. It can detect the tips of your fingers to like 0.5 millimeter, and it can detect the position of your tips of the fingers, the velocity. It can detect gestures. It can detect the palm position. It can also detect like if you're doing like a palming action, like you're palming a basketball. It can tell you where's the center of the ball and also the radius of the ball. There's a lot of things like that. Swiping gestures, circle gestures, key tapping, pointing, it's very powerful, and I feel like it's definitely the future. And it's actually going to be released next month, July 22nd, for a price point around, I think, $70 or $79. So it's pretty cheap, pretty affordable, and it's quite small. And this is actually the development kit, and it's pretty close to the consumer hardware. I think it might be a little smaller, but I'm pretty sure this is basically this. They're also developing an OEM model, which you can actually embed into laptops. So in the future, like HP laptops or Acer can have Leap Motion actually embedded, where your trackpad is. So this is definitely a futurist technology. And if you read a lot of internet blogs or news articles or stuff on the internet about the Leap Motion, a lot of people kind of relate this device to. For those of you who've seen Minority Report, that shit that Tom Cruise uses. He's swiping through the windows and stuff. And from a science fiction perspective, it's very cool. And like, if you're watching a movie, it's very visually impressive. But from a usability perspective, it's not very applicable because, first of all, if you're doing this for just a few minutes, you have arm fatigue. Your arm gets tired really quickly, and just doing simple gestures with your whole body is not very fun, as cool as it looks with Tom Cruise doing it. But for example, like on an iPhone, you have a swiping gesture where you swipe to the next page. Like Tom Cruise, for example, would do something like this. Swipe these fucking huge ass windows. But then, it's not really applicable.
He has to go and shoot some people after that, so
yeah,
he needs a training.
That's true. So it's not really about big gestures. It's more micro gestures. You do perform very small actions that have huge consequences. So you do like a swiping action like this, or for example, if you want to zoom in, instead of doing this, zooming into the Google Maps, you would just pinch like this. just stuff like that. And they want to really focus on usability and just moving your fingers. There's no fatigue, and yeah, it's they're just trying to make hand gestures really usable and practical and mass market. So the company Leap Motion, they're very well funded, and I think recent round they got like 20 million US venture capitalist money. So currently they're at about 45 million. And also recently they also got another 25 million to just to develop apps. So they have this really nice piece of software, and they have a shit ton of money, but then they're kind of hungry for apps. So they recently contacted me, a few months ago, and they asked me if I would be interested in developing, interactive applications with it. So yeah, so I left Q Games now. I'm not working for the company. I'm a freelancer, but I'm just helping develop an application that when they release this device on July 22nd, whatever I make, hopefully will be featured. And right now they have about, I think, 700,000 pre-orders. So it's pretty legit, and and yeah, it's I think it'll do quite well. So I've been working on this application, this thing, for a little less than 1 month. Just trying to figure out what I want to do and just testing out the API and stuff like that. And this is a screenshot of the thing I'm working on. It's called Lotus, and yeah, so the concept behind Lotus is it is a interactive audiovisual experience, and it's heavily inspired by a Nintendo DS game called Electroplankton. I don't know if has any of you seen it? Yeah. It's very cool, and it's not a game in the traditional sense. It doesn't have like traditional game mechanics. It's more about just jamming along with your Electroplankton, just creating nice music and tones and stuff. And so yeah, my Lotus thing is heavily inspired by that. And I'm a graphics programmer, so I have a huge focus on procedurally generated graphics. So everything here, I think, besides the fonts are procedurally generated, all the vertices and stuff like that. And the goal of this application is to allow the user to create music. And music is a very primal element. It's been there since the dawn of man. And I feel like people like to express themselves with music. People, they wear the shirts of their favorite bands, or they talk about the music of their favorite bands because they can relate with the band or the music they're saying, or the music they're singing. And some people, take it next level in which they actually create music. They spend a decade, 2 decades just mastering piano or guitar or something like that. And I feel like the general population, they want to express themselves with music, but they don't want to devote the decades or years of time to learning effective mastering an instrument. But with this modern era, we have stuff like electronic synthesizers, where you could we have stuff like arpeggiators, where all you need to do is press the button on a keyboard and just plays a scale or chord in the arpeggiator. You also have things like drum loops, and like even if you have the worst intonation in the world, all you need to do is press the vocoder and just sing, and then even if you have no sense of pitch, through vocoder you have perfect pitch. So in the modern age, there's tons of new music technologies that enable people who are not really musically gifted or who don't want to invest that much time into learning an instrument to actually create music. And that's sort of a thing that I'm very passionate about, and something that I want to enable with my app, Lotus. So about creating music, this project is 2 people, just me. I'm doing the programming, like sort of design and graphics and stuff, and then this guy called Andrew Norman. He is a sound designer, musician, and he's a musician from Seattle. He does a lot of stuff for video games. Like he recently did the sound design for Sword and Sorcery on iOS. And he also does a lot of random stuff, like he did the interface sounds for the Xbox 360. There's a lot of random stuff like that. And I partnered up with him to make this. So some of the before I dive into some of the tech, very likely, it's coded in C and C++. Pretty much you have to code in C and C++ because I'm aiming for cross-platform. So when I ship it, it's going to be for Windows and Mac. And the graphics, obviously, I use OpenGL. And the engine I created actually runs on Windows, Mac, and iOS as well. So I had to find a intersecting subset of OpenGL that intersects with OpenGL ES2 as well as OpenGL desktop version, and I found that the subset feature set is around OpenGL 1.4, and which is a shame because I really want to use a lot of the OpenGL 4 stuff like compute shaders and stuff like that, but unfortunately for this project, not really. Have not engineered my engine that way. For scripting, I use GameMonkey. We use GameMonkey at Q Games for all of our Pixel Jump series. And for the sound, I use FMOD, which is a sound API tool. So here is the menu scene. And in my Lotus app, you have the menu, and you also have 4 mini apps. So each mini app is sort of like a musical toy. Think of something like electric piano, it's just one stage. And you sort of just each app, you just make music and jam, just have fun. And so I was thinking about a way to allow the user to interact with the menu using only gestures. And I was thinking, well, why don't you just literally just let them choose which app? So you have 4 apps, and all you have to do is you have the leap, and you go app 1, and it goes to app 1, or app 3, and chooses app 3. So that is sort of the menu design. And this is the first app. It's called Fractals, and it is heavily inspired by the psychedelic era of the 1960s or something. And the sound design is Eastern Asian, Indian sounds. There's clavichords and stars and East Asian bongos. And well, the original concept is you have these 6 boxes that exist on a sphere, and you sort of rotate the sphere like an old school mouse wheel. So you have these things that are just rotating on a sphere, and you just rotate it around. And these boxes each have a sound emitter attached to it, and because of the rotational velocity, you have like the Doppler effect. So as the boxes move away from you, the frequency expands, and you have the Doppler effect with the frequency shifting to the left. And as it comes towards you, the wave contracts, and you have the Doppler effect with the frequency shifting to the right. So it was inspired by, for those of you who are into like music amps or speakers, there's like this thing called a Leslie speaker, which is basically it's like a piano guitar speaker. We have 2 speaker cones like this, and it's rotating on an axis like this. And it plays the sound, and it rotates, and it creates like a Doppler effect. It's very, very ethereal. And as a side note, the first time I heard the Leslie effect was, I think, in high school, when I was listening to a Jimi Hendrix album called Access Cool as Love. There's a song in it called Little Wing, and in the song, you hear like this really, really weird Doppler effect when Jimi Hendrix plays guitar. And when I was researching, like, oh, how do you make that sound? It turns out to be the Leslie speaker. So I was really into it, and then I found out, finally a way to actually integrate it to something I make. So. The second scene is called Singers, and aesthetically it's more fun, cute, more playful. And in the scene there's 4 of these singers, and you spin them with your gestures like this, and you rotate their face. They have this hexagon that just rotates around. And as it rotates, it sings, and the faster you rotate it, it goes higher pitch. And if you rotate it a lot, then it spawns like a sing out of its head. And it's very playful, and you just try to jam and make them sing chords and stuff. And to offset the cutesy visual aesthetic, actually for the sound design, I went with hip hop. So it's actually turned out quite well. And so my third thing is called ribbons, and to offset the cutesy design and the psychedelic fractal design, this one's more like serene and peaceful, and it's inspired by like Chinese ribbon dance, where you have these people who have batons and they have attachments of ribbon and do like these really graceful, swoop and stuff. But instead of batons, it's attached to your fingertips, and you do like these nice, graceful gestures, and these ribbons like swim and wave in the air very gracefully. And you have like a nice reflection on the water, and that's the design. And the fourth one is one I showed earlier called face, because it's someone's face. And this one is more like electronica inspired, so I took a lot of inspiration from like Radiohead's OK Computer. When you think about like the dehumanization of technology, that kind of feeling is something I wanted to convey. And yeah, so I've been working on this for over 3 weeks now, less than a month, and I've encountered a lot of problems just working with it, and just letting people play test it. I noticed a few things, like for example, in the leap motion inside it is embedded 2 perspective cameras, and which has like their own field of view. And with these 2 perspective cameras, it collects cloud point data, and it uses the cloud point data in a lot of math and number crunching in order to determine the position of your fingers, the gestures and stuff. So a lot of it is very statistically driven. And just like your eyes have a field of view, which you can't really see outside of your vision or whatever. And well, for this one, it has an angle of maybe 70 degrees or something, field of view. But for a lot of users, when you see them use it, they put it on the desk. They move their hand around like this, and they don't really understand that their hand is outside of the field of view, because all they're doing is just like, okay, I have this on a desk. I can assume that everywhere now is just this infinite play field. But when you're moving around, it's outside of field of view. People get like kind of confused, and they think it's a little glitchy. So it's definitely a thing people have to overcome. And the second thing is the feedback. So a lot of the most successful, human interfaces, like the mouse, which has been here for almost half a century, and the keyboard as well. Like when you interact with it, when you click, you get a very successful event registered when you click down. And a lot of these most famous or most successful projects have really nice tactile feedback. Like keyboards, for example, you could write an entire essay with your eyes closed, because you trust that when you type, all the keys get registered, because it has a very, very nice tactile response. But with the leap, you don't really get the tactile response or tactile feedback. The only feedback you get is with something you see on the screen or something you hear on the music. But then if you do a gesture or whatever, you're not really sure if it registered or not. Because I think the modern human is more conditioned to respond better to tactile feedback than they are to something like wavy gestures, like visual feedback. So I think for mass market appeal, it has to be a lot of conditions for people to get used to something like this. And third of all, it's the finger tracking. So you have 2 cameras that are facing outwards like this. And then the most optimal way to interact with it is to put 5 fingers like this, so you can very clearly see all 5 fingers. You can easily detect them and see and track them as it moves. But then if you notice, a lot of people who first try it, they don't really know that. All they do, they start doing this stuff, like hula, or they think they're like in a rave or something. And then when their hands are like this, orthogonal to the point of view or to the field of view, it can only see the bottom of your pinky, and it really can only guess what the other fingers are doing. But then you notice a lot of people when you're doing it, they're just doing like this, they're trying to like swipe and stuff like that, and it really has a hard time tracking it for people who don't understand how it works. So that's another thing that has to be overcome in order for this device to be successful. So okay, I'm going to briefly show it. And so there's probably a lot of bugs because it's only been 3 months or 3 weeks. So please, if it crashes, so first of all, I just want to show you briefly before we jump in. This is so it looks like this. So I'm interacting with my hand, and you see it's very responsive, very fast, and I can do gestures like rotation. Just going to rotate the camera. I'll rotate. So you see I have my fingers like this. It's very fast, very accurate, very responsive. I can even do 2 hands. And I can do these magenta things are circle gestures I do, and I can just do like P-taps. These little droplets are from P-taps. I can do swipes. So you see these lines that sign on lines that it's just very very responsive, very very powerful. It's very impressive software. And for $70, it's quite ideal. All right, so I'm just going to start it from the very beginning. Sorry. Okay, and so this is the intro scene, and we have, I'm trying to think of a way for players to get acquainted with, the leap and stuff. I assume that they never used it before, so I try to set up a scene that makes it as obvious and simple as possible, just for people to get acclimated. So you have this eye thing, and then you just basically have this. It follows your eye, so the user kind of think, oh, what should I do with the eye? Go. It's developing eye. It's registered, and it starts into the menu. So you have this menu, and you have these 4 apps on top, and basically use your hands. And I can do app 1, app 2, app 3, app 4, stuff like that. So basically it counts the number of fingers that you're displaying. So I go, okay, now I'm going to go app 2. And now it launches app 2. So this is the fractal scene. And there's some audio problems, so you gotta excuse. There's some actually aliasing because I'm doing a lot of DSPs with it. So I've implemented a flanger with a auto pan, and then we have flanger with auto pads with low bit rate. You get a lot of aliasing on the side. So you grab the boxes, and you rotate like this, and then you throw. When you grab the boxes, I'll think for DSP, you would think of like if you're closing a door on a concert, you apply a low pass filter to make all the high tones go away and assume that you only need low tones shining. So that's a DSP. And I can switch instruments. So right now these are boxes. I can switch them to now I have these squares. I play the sound. I play like a East Indian flute. Another one that's more like a sitar. And then yeah, basically you just jam or throw. It's very psychedelic. So yeah, seizures. So yeah, that's the scene. And then that's sort of one of the complete scenes. I think the audio still needs to be reworked. And here's the singer scene. Yeah, this dude and telling you spin my face. So these are okay, try to figure it out and you spin. It starts off with a hip hop thing. You see if you spin the face, if you spin it a lot, it spawns like a thing on its head. On scene that was just kind of mess around. You could spawn a little fingers camera. So those are the two complete scenes, or feature complete, and it definitely needs a lot of iteration and just testing to get it kind of feeling right. So here's another scene that I've been kind of prototyping. It's the ribbon scene I was talking about. So from a tech perspective, these ribbons are controlled by this algorithm called Verlet physics, which is using a lot of like 3D ragdoll, like Team Fortress 2's Verlet. And I just connected all these ribbons using Verlet, and then so you have these 4 ribbons. Each of them are connected to one of your fingers. So if you put your hand in it with one hand, and I got this ribbon connected, and it's I can do swirl actions which spawns these particles. Right now there's no sound, so it's an excuse. I could do like swiping gestures that spawns these arrows. And also have all 4. So it's sort of like tries to make it. It's very. I think this one's the most intuitive, but just have to figure out a good sound design to implement. And the final one is something that it's very. There's nothing really. It's the face scene. And okay. Well, here's the face, and then you can't really do anything with it right now. You could just freehand it, and things like a debug render. I was planning to make it more like you control like maybe a 3D velocity or vector field or something, or something called like chromas, which is like fluid dynamics algorithm to spawn particles and check them in really nice ways like convections and stuff like that. And yeah, that's about it. So.